So our first problem is going to be adding together the rational functions 4x plus 2 over x plus 3 with 6x plus 4 over x plus 7. So now, just like how in fractions, we first need to make these denominators equal to each other, we need to do it with adding rational functions. So just like in fractions where you have 1 equal to 2 over 2 and you're multiplying it by 1 to get these denominators equal to each other, we can also multiply them by, let's say, x plus 1 over x plus 1 or 2x plus 3 over 2x plus 3. So keeping that in mind, we can now change these denominators using this same property from adding fractions. So take this 4x2 over x plus 3 and multiply it by x plus 7 over x plus 7, and take this 6x plus 4 and multiply it by x plus 3 over x plus 3. And what you have now is one fraction that becomes 4x plus 2 times x plus 7 plus 6x plus 4 times x plus 3 all over this denominator x plus 7 x plus 3. And so if we simplify a little bit, we could, so we would have here 4x squared plus 2x plus 28x plus 14 plus 6x squared plus 4x plus 18x plus 12 all over x squared plus 7x plus 3x plus 21. And then just combine like terms, we end up with the answer 10x squared plus, let's see, so we have 30, and then 22, so that means this is 52x plus 26 all over x squared plus 10x plus 21. So that's how you get, so that's how you would add 4x plus 2 over x plus 3 plus 6x plus 4 over x plus 7. So you just go through these series of steps, and eventually you get your answer down here. And I just want to make sure you know that this is also equal to 4x plus 2, x plus 7, x plus 7, x plus 3, plus 6x plus 4, x plus 3 times x plus 3 over x plus 7, x plus 3. I just want to make sure you guys know that these, that this could also be rewritten as that. I didn't skip a step here. This is just a way sometimes that requires less writing, so I can go through the problem quicker. But I just want to make sure you know that as well. So let's do a second example. So our two functions are going to be 4x plus 7 over x plus 1 plus 5x plus 3 over x plus 2. So again, what you want to do is you want to get your denominators equal to each other. So you do that by just multiplying each fraction, or rational function in this case, by a factor of 1. So that way you then get, x plus 2 times 4x plus 7 over x plus 2 times x plus 1. Then add that to 5x plus 3 times x plus 1 over x plus 2 times x plus 1. And now these fractions have the same denominator, and you can add them together. So you can add them together by going like this. So let's just simplify the top real quick. 5x squared plus 3x plus 5x, and I'm just using FOIL here, just like that. And then the bottom is, and again, I'm just using FOIL. So x squared, 2x plus 1x plus 2. All right, and that's the same over here. And so what we get when we combine like terms is 9x squared plus, and this is 15 here, and this is 8. So 15 plus 8 is 15 plus 8, let's see real quick, 23. So 23x plus 17 all over x squared plus 3x plus 2. And so that's how you would add 4x plus 7 over x plus 1 to 5x plus 3 over x plus 2. So that's how you would add these two together. So I'm just going to box this just to show you where the original problem was. Alrighty, on to our next example. So I thought I'd end this video on a rather difficult problem. And so what we'll be adding together is x squared plus x plus 31 over x squared minus 4, and then plus 3x squared plus 2x plus 1 over x squared plus 4x plus 4. Now, you might be thinking, man, this is a hard problem, and it is a hard problem. However, there's a nifty little shortcut. Because even though we do need to get these denominators to be equal, we don't have to multiply it by this entire quadratic equation. Because if we factor each of these denominators into their linear components, what you notice is that they already share one factor. And so to get this denominator equal to this denominator, we only need to multiply it by one more linear factor. So we multiply this side by x plus 2 over x plus 2. And this side, we multiply by x minus 2 over x minus 2. And so now we can solve the entire function, because you can see here, once you multiply this together, you have this denominator equal to this denominator. All right, so if we multiply this through, we're going to get one big and messy function. So I'm going to make a little box chart here. And so I'm going to put x squared, x 31 here, and then x plus 2 here. And so we get x cubed, x squared, 31x, 2x squared, 2x, and then 31 times 2 is 62. So for this top part, this numerator here, we get x cubed plus 3x squared plus 33x plus 62. All right, so for this numerator over here, we got to create another box chart, because it's going to be a big polynomial, and I don't really want to mess up. So x minus 2, all right, and then we have 3x squared plus 2x plus 1. And so now we just fill up the boxes. So we have 3x cubed, 2x squared, x, 6x squared, 4x plus 2. And so, and this is also, we got to make sure to, sorry, I didn't say this, these are all negatives. This is negative 6x squared, this is negative 4x, and this is negative 2, because I forgot to put in the negative 2. So now we have 3x3, and then combining like terms, well, 2 minus 6, that's negative 4, so we get negative 4x squared, and then x minus 4x, that's negative 3x, and then negative 2, so minus 2. And so the denominator also is going to be a little bit more complicated. So I'm just going to make another box. So I'm just going to solve this side since we know this side's going to be the same as this side, just so I can see it. I'm just going to bring this down for you so you can see it better. And let's see. So we have x squared plus 4x plus 4, and then we have x minus 2. So we have x cubed plus 4x squared plus 4x minus 2x squared minus 8x minus 8. And so now when you write out the denominator, you have x cubed minus 2x squared minus 4x minus 8. And so now we have our numerator for the first fraction, the numerator for the second fraction, and the denominator for both fractions. All right, so I'm just going to take this information and I'm going to rewrite it onto this piece of paper here. So we're going to have x cubed plus 3x squared plus 33x plus 62 all over x cubed plus 2x squared minus 4x minus 8. So, right, because here's the first numerator thing here. This is where the denominator comes from. And then now, see this numerator right here for the second fraction. 3x cubed minus 4x squared minus 3x minus 2. And then all over x cubed plus 2x squared minus 4x minus 8. And so now we can add this function together by combining like terms. So you have 4x cubed minus x squared plus 30x plus 60, because this is 62 minus 2, so that's 60, all over x cubed plus 2x squared minus 4x minus 8. And so there's your final answer to this big problem. And so if this confuses you, this is probably more complicated than what you're going to see in class, but I figured, hey, why not? So feel free to leave questions in the comments below, and thank you for watching this video, and I hope it helps.